Okay, so now we're looking for angle B and angle C, so let's just see what we have. Okay, so we know that A squared is equal to B squared plus C squared minus 2BC cosine A. However, we're looking for B and C, so this may or may not be much use to us. We do know that B squared is equal to A squared plus C squared minus 2AC cosine B. This we're going to use, because look what we got. We know what A and C are. Here is A, here is C as far as lengths. And we also know what B is. Let's just plug this in. If we solve for cosine B is equal to B squared. I'm going to subtract A squared and C squared. So this is B squared minus A squared minus C squared divided by this, divided by minus 2A and C. And I'm going to use this to figure out what the Arcos is. So let's plug and chug. I guess I'll write this up. B, so this is 65 squared minus 100 squared minus 50 squared divided by minus 2 times 100 times 50. Okay, and I'm just going to do the pieces separately. The top will be 65 squared minus 100 squared minus 50 squared. This is minus 8275, and the bottom's going to be 2 minus times 100 times 50. This is minus 10,000, and now I'm going to do some division here. 8275, it's negative, flip it over so it looks right. So we have this, cosine B is equal to 82, just really wants to be 7. 8275. That means that the Arcos of 0.8275 will equal B. And I'm going to punch that up right now, and this tells me that B is 34 degrees. It actually says B is 34.1572 and change. I'm going to the 100th place for these. The book tends to go to the 10th place. Whatever. We look to the right of the 100th place. It's 5 or above. We kill this. This goes up to 1, or this goes up to 6. It goes up 1. So this is 34.16 degrees. Okay, that was groovy. Yes, I said groovy. So now, similarly, we're going to solve for C by using this formula. And you'll notice I'm writing these down and saying it out loud every time. You really want to memorize this. Trust me, you want this in your memory banks. We know that C squared is equal to, A squared. These markers are so messy. A squared plus B squared minus 2AB cosine C. Doing some algebra, that means that cosine of C is going to equal C squared minus A squared minus B squared divided by minus 2AB. And let me plug the numbers in. This is going to be 65 squared minus 100 squared minus 50 squared. Do I believe that? Oops, no, I don't, because I did it wrong. Let's see. So C squared is going to be 50 squared minus A squared, which is 100 squared, minus B squared, which is 65 squared, divided by minus 2 times A, which is 100, times B, which is 65. Now I'm going to use my calculator. I'll figure out the top first. 50 squared minus 100 squared minus 65 squared. This is minus 1170 or 11,725 divided by 2 negative times 100 times 65. So this is minus 1,300. Let me do the division here. 1725, the minus sign, flip it over so it works. So I have this, cosine of C is equal to 0.90192, blah, 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 blah. I don't have to truncate it, which means cut it off, because I'm just going to use the calculator. I'm going to hit second button, Arcos. This says that cosine of, or this says that angle C, not cosine, angle C is equal to 25.58799 and change. We're approximating to the 100ths. This is above 5, so this is going to be 25.59 degrees. So let me write it up here. This is 25.29 degrees. Okay, so we just saw that even though we were not given any angles, as long as we were given all 3 of the sides, we could figure this out. A question for those of you who are thinking, what about if I only have 2 sides and no angles? This is going to be a problem, isn't it? Now I want to show you another nice little trick here. This is going to be leading in to the next lecture, the law of sines, which will be actually probably a couple after this, but I just want to show it to you now. Look at what we got here. So the sine of B over B equals the sine of C over C. And this is actually, here's what's driving nuts. This is side B, and this is side C. This is the law of sines. Let's see if this works first. The reason why I want to introduce it slowly is there's a bit of ambiguity, which we'll discuss, but don't worry about it. So according to this, the sine of, and we want to solve for sine of C, right, to figure out angle C is. So that means that C multiplied little side C by here and canceled it out. Sine C is equal to side C times sine B, or let's see, 34.16 degrees. Side C is, what, 50 feet? And divided by B is 65. Let's just see here. Let's see if it works. 34.16, I'm in degrees, I hit the sine. It's like 0.56 and some change, times 50, divided by 65. This is approximately 0.431927, blah, 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 blah. So if sine, this is sine B is equal to 0.431927 and change. That means that the arc sine of 0.431927 and change is equal to, I hit arc sine, and it says 25.56 degrees. 25, here, this says 25.589. This is approximately 25.59 degrees. Now you'll notice a discrepancy here, and I have to think about what just happened. Did I write this down wrong? Notice this is 25.29. This claims that it's 25.59. Okay, so what just happened here? So I used something we're going to learn about, which is the law of sines. It says sine of angle A divided by little a equals the sine of angle B divided by little b, which equals the sine of angle C divided by little c. This is a really nice little deal. However, when I used it, I got a different answer. But I noticed it looks suspiciously like the professor's a geezer and just wrote down the wrong thing. So this is what I did. I resolved for cosine C. So what is this? This is cosine of C is equal to C squared minus A squared minus B squared divided by minus 2AB. If you plug those numbers in again, what you will find is that this is in fact 25.59. And I went and looked in the book just to make sure that I didn't manage to screw this up, and it's just fine.